Right. So if we're, I think everyone's here. It's 12:38. We should start the lecture. I think you already know what the endowment effect is. And if you feel like you already owned this $10, it'll be painful for you to lose it. Whereas if you don't have that $10, you still want to get it, but you wouldn't experience the big pain of not getting it. You understand that. The thing about prospect theory is they took that effect, the endowment effect, and built it into their model so that everyone in the model of prospect theory already has an endowment effect built in. It's not some extra thing you need to consider. And because the reference point is the center of the two axes, if you watched the video on the value function, I think I didn't edit those graphs. I'm not a graphic designer, so I don't think I could do that. But the team of people that I worked with to make these videos, I think they did a great job sort of explaining the axes, putting that dot there in the center as the reference point, and then you get to see the arrow go, I don't know if you're seeing a reflection of me or what, but up and to the right is this domain of gains, where if I'm considering an outcome that's improved my situation, I think of that as a gain. And I have this increased value in the domain of gains, but it's concave. It's concave. And in the domain of losses, I think of that as a bad thing. If I'm losing money, or if I'm losing a mug, I'm losing something relative to my reference point, my value goes down, but it's actually convex in the domain of losses. We have a value function which is concave in the domain of gains and convex in the domain of losses. That is, that is built into the value function of prospect theory because Kahneman and Tversky observed people behaving in a way that's consistent with that. You remember the video I gave this example of a health policy where 600 people could die, or you could save 200 people. You have this choice. Do I want to take a risk? You guys remember this example? I'm gonna go back and start from the beginning of prospect theory. You guys, I hope you've learned already what are the most important parts of prospect theory. That was the idea of this course. Was you are going to watch some videos on your own and read some of the material on your own, but now we can talk about it. I'd like to talk about prospect theory, and I do have some slides. So let me share. Where'd they go? I posted it in course documents. So if you go to course documents, lecture notes, number 6 is prospect theory. So I'll open that now. It's opening. And I will share it. It's just not even an option for me to share. Sorry, my computer's being slow. Here we go. Share screen, prospect theory. Okay, so here are my slides on prospect theory. Maybe you agree with what James said, that the paper. Sorry, I still don't think it's being shared properly. You are screen sharing, okay? Current slide. I think this is good. Okay, guys. Maybe you agree with James that the paper I had you read was a little wordy, and it was actually a pretty academic paper. I agree with this. maybe it was the first time I had you read a paper that was written more for academics than for a general audience. But let's talk about it now. Let's talk about the point of prospect theory. We've actually already, let's skip this slide. We already did it. Okay. In my video, I gave this example with $1 million and $2 million. That's such a huge amount of money. Sometimes it's not as practical to even think about it. It's maybe better to think about what would you choose if it was 3,000 or 4,000, right? So here's an example I've often given class when I'm presenting this. And that is, would you rather have $3,000 for sure or $4,000 with 80% probability and 0 without? And you guys, would you guys answer that? What would you rather have now? Would you rather have, so A is type A if you would rather have the gamble, which is to try to get $4,000. You know, like you're spinning a wheel and 80% of the time you spin the wheel, you get $4,000 and the other times you get nothing. A equals $4,000, 80%. But B is the sure thing where you definitely get $3,000. Like, try to imagine yourself actually getting this money. If you choose number B, prospect B, you definitely get $3,000. Doesn't that sound great? You know? A lot of people are choosing B. 1, 2, 3, 4, B. Brody chooses A, but I see more B's than A's. Good, that means you guys are normal. Most people, 80% of people in Kahneman Tversky's paper chose B of these two options. And why do they choose B? Why you guys choosing B? Why are you choosing B? Someone explain. Why don't you want to take the risk to get 4,000 instead of 3,000? Any reason? Just to play it safe? There's no right or wrong answer. I'm just curious. Oh, you're gonna chat. Margin utility of first 3 grain is way higher. Oh wow, that's a complicated answer. All right. Not sure enough a thing. Yeah. Good. You know, I have to say, I think I would make the same decision. If somebody offered me $3,000 for sure, I think I would take it. Like, oh great, man, you get $3,000. Sounds like a pretty good deal. I don't have to do anything. Just $3,000. Why not take it? Whereas the 4,000, you might end up with nothing. They're both a few months' rent. Okay, good one, Peter. I like that explanation. Okay, now let's think about the other one, which is I'm going to take these probabilities and change them. Now prospect C versus prospect D. In prospect C, you get $4,000 with a 20% chance. Or in prospect D, where you get $3,000 with a 25% chance. Which would you rather have of those? Would you rather have C or D? And now with C or D, nothing is certain. In fact, you're probably going to lose either way, right? In both C and D, you're more likely to end up with nothing. But the question is, if you do win, would you rather get this 4,000 or 3,000? And you do have a higher probability with D. Notice, with D you have 25%, and with C you only have 20%. So you're making it a little bit more likely to win if you choose D. But actually C gives you $4,000. And I think I've noticed, I see some C's and some D's. I see more C's than D's. Good, that means you guys are normal. You guys are normal in both cases because more people chose B than A and more people chose C than D. You can see in the past, I've asked my behavioral economics students, that's what BE students stands for. And they weren't actually as strong as you guys were, but they still had this flip. And the fact that you choose B over A, but C over D is an example of a paradox. I tried to explain it in my video about the probability weighting function, but I want to go over it again now with you here. You have a chance to talk to me about it. Why is this a paradox? Because I could understand anybody watching this saying it's not a paradox. I chose B over A because I wanted the sure thing. $3,000 for sure is way better than uh, having a chance of getting nothing. So I'm going to choose B. And then I chose C over D because C just has a lot more money. C has an extra $1,000, and the fact that the probabilities are a little bit different doesn't really matter to me because, um, in both cases, I'm probably not going to win. I'm thinking about what happens if I do win. If I do win, I'd rather get 4,000 than 3,000. Like you can rationalize it in your head that way, and I kind of agree. I understand that. I get that. But what are we doing here? What's our job? We're behavioral economists. That's the name of the class. I'm trying to train you as a student to think about things the same way that a behavioral economist would think about it. Remember our first class, we talked about what's the point? What's the point of behavioral economics? It's to refine standard economic theory, to include psychological realism into a model of economic theory that wasn't there before. So this psychological realism, by that I just mean what's actually going on in your brain when you think about this problem. That's what Kahneman and Tversky did. They included the psychological realism of what is it actually that you're thinking about when you're choosing among these different prospects into this decision under uncertainty that you have to make. And so they found a way to rationalize it in some sense, or at least it becomes consistent once you use prospect theory. But let's talk before we get to the solution that Kahneman and Tversky had. Sorry, let's read what Peter said. If C and D would be chosen differently, like 1/5 and 1/4 instead of percentages, because 5% sounds different, sounds smaller. So yeah, you're arguing now that there could be some kind of a framing effect, Peter, in terms of percentages as opposed to fractions, and how something sounds. That's very possible. I'm going to claim right now, though, that's not what's going on. This is not just like because people are bad at math. This is not just people can't tell the difference between 1/5 and 20%, and they get kind of tricked because of that. That may be that may be happening, but I would argue, and I think if Daniel Kahneman were here, he would argue also that it's not that simple. That people are just bad at fractions and percentages. There's something else more fundamentally going on in their minds when they make these decisions. And it's how they truly feel about these probabilities that's happening. Notice the dollar amount hasn't changed. A and B, the dollar amounts are 4,000 and 3,000. C and D, the dollar amounts are 4,000 and 3,000. So those dollar amounts haven't changed. It's not really about the dollar amounts. It's about the probabilities. So I want to talk about how we feel about the probabilities. And I would argue, can I put on hold? Before I argue the solution, let's explain the paradox a little bit better. And that is, it's a paradox that's due to an economist called Maurice Allais. Looks like Allais, but he's French, Allais. It says that if you choose B over A and C over D, it's a violation of expected utility theory. I didn't put the word theory on there, but in fact it is. I should have said theory because the theory says you will choose whichever option gives you the highest expected utility. Expected utility is a concept. Expected utility theory is a prediction of how you will behave. So maybe it's not expected utility that's being violated. It's expected utility theory is violated because you should never switch between choosing B and over A and choosing C over D. It's not really a switch, but it doesn't make sense. And we can do the math to see why. If this were a whiteboard, I would do a lot more math. I'm sorry, I don't have a good whiteboard to work on with you. So I'm going to type some things in the chat here. Let's just say whatever the expected utility of option B is, you know, I'm going to emphasize is X. Why do I do that? I'm sorry, A. I'm sorry. The expected utility of option A is it's some number. The whole theory is that you can boil everything down in expectation down to a single number. The expected utility theory of A is X. Just say that. And let's say when I'm talking about prospect A. And the expected utility of B is Y. Okay? If you choose B over A, that means X has to be greater than Y, isn't it? Nope, I got it backwards. I can't delete this, can I? That was wrong. Gosh, a real whiteboard I can just see. Whoa. Oh, you can't see anything I'm doing. Thank you, Peter. Oh, I'm glad because I made a mistake. Okay, I'm gonna type it correctly this time. Gosh, I feel like an idiot. Sorry about that, guys. I think I clicked on something and I wasn't being sent to me. The expected utility of A is X. How about now? Can you see this?
Nope. You're just sharing the slide right now.
So you can't see what's in the chat. Look in the chat.
Oh, no, it just showed up. Okay, yeah, I see that.
Yeah. So I'm typing right now in the chat. It's like if I were writing something on the whiteboard, but just I can't really do the math the way I want to, but I want to talk about the math. Okay. I'm gonna keep writing. If you choose B over A, that means Y is greater than X. I want to make sure everyone gets that point that I just had. This is the whole point of expected utility theory. You choose whatever gives you the highest expected utility. So if you're choosing B over A, that means Y has to be greater than X, right? Does everyone agree with that point? I think if you don't get that point, then I think you're missing something. And it won't make sense to go on if you can't understand that point. But that's what expected utility is. Okay, now notice that C, if we compare A and C is exactly the same outcome as A, only with the probabilities multiplied by 1/4. And there's a principle of expected utility theory that says probabilities are multiplied by the outcomes. And so if I take the same outcomes with the same probabilities, but multiply their probabilities by 1/4, the expected utility needs to be multiplied by 1/4. So this is the math. The math says that because the probability of C is exactly 1/4 that of A, then expected utility of C is X over 4. Does everyone get that? C, let me go back to the things here. Notice that C, prospect C, is exactly 1/4 the probability of prospect A. Therefore, the expected utility of C has to be exactly 1/4 the expected utility of A. And the same is true. The same thing is true for D. Also, D is 1/4 probability, or I should say 1/4 chance of B. So expected utility of D equals y over 4. If you choose C over D, then that means x over 4 is greater than y over 4. Because that's the point of expected utility theory. It means it's a prediction that says you
Hey,
will
what's
choose,
up?
pardon?
Hey, I'll call you back in a little bit, okay? I'm in a lecture, but it should be over not too long.
I'm going to mute that guy. He's talking, and we're all listening to him talk. Okay, if you choose C over D, then x over 4 is greater than y over 4. But from the first thing, we know that y is greater than x. And y greater than x is a contradiction to x over 4 greater than y over 4. That is the paradox. Those two inequalities cannot exist at the same time. I mean, just multiply it by 4 and you'll see that that's impossible. So remember, we haven't assumed anything other than there's some expected utility of A, and C must give you 1/4 of it. There's some expected utility of B, and D must give you 1/4 of it. Expected utility theory says I'll choose the one with the highest expected utility. It's impossible for someone to choose B over A and C over D. Yet, that's what we observe the majority of people doing. Therefore, there's this paradox. Okay, hopefully, maybe now, I don't know if I've helped. Does anybody else have any questions over why this is a paradox? Why what I have on the screen right now, this, B is bolded and C is bolded, it's a paradox of expected utility theory. Okay? Let's talk about the answer to it, the solution. How do you resolve this paradox? Oh, by the way, let me just point out, the shape of the utility function isn't possible to explain this anomaly. It doesn't matter exactly how much better $4,000 is than 3,000. You could be the kind of person who is completely risk averse, risk neutral, risk seeking. It does not matter. In all cases, this is a violation of expected utility theory. So how can we explain it? How do Kahneman and Tversky explain it? They do it with a probability weighting function. Remember, weighting is W-E-I-G-H-T, that type of weight. I noticed in one of my videos, there's closed captioning, and for some reason, they thought weighting was W-A-I-T-I-N-G. It's clearly not that type of weighting. Okay. I didn't do the closed captions. Those were just automatically generated. How does the probability weighting function explain this paradox? It's because exactly the way we feel about 20% and 25% is sort of flattened. We're insensitive to those changes. Remember, psychological realism, this is something that's psychologically real for us. We're not computers. We're not that good about telling the difference between two probabilities, 20 and 25%. And because we are insensitive to that change, we're not completely insensitive. We do know there's a difference. If somebody asked us, hey, is there a difference between a 20% chance of rain and a 25% chance of rain? Of course, we would say, yeah, 25 means it's a little bit more likely to rain. We would get that. But what we don't get is exactly how different that is and exactly how much of a difference it should make in our lives. Like whether or not we should grab an umbrella with us on the way out the door. If somebody says 20 or 25% chance of rain, it's not going to make a difference over whether or not we grab the umbrella. We're going to grab the umbrella if it's there and we can, and we're not if it's not there and we can't. Okay, that's the idea. And Also, there's one more thing I want to say about this, which I will on the next slide, and that's there's a certainty effect. When we get something that's certain, it's almost like putting our mind at ease, where we don't have to worry about that uncertainty anymore because we know we're going to get it. We get that benefit for the 3,000. And I hesitate to call it a benefit always, because sometimes the certainty is for a bad thing, right? Imagine losing $3,000 with certainty. That would be bad. We would think to ourselves, "Oh no, I want to avoid that." So it's not always that we prefer something that's certain. I don't think that's true, that we always prefer something that's certain. It's that we kind of overweight it as like in its importance. Okay, let's go on. You guys have any questions? The need to improve expected utility theory. This is one of those needs. And here's how the probability weighting function does that. I said I would kind of make this shorter, didn't I? Let's see what we can do. So these are the two effects that I have just been talking about. I hope they make sense. Outcomes near 100% certainty are weighted more heavily. Same thing with 0%. Weighted in our decisions, like how much attention do we give to those things? I'll give you some more examples. Insensitivity to probability changes. This is another effect, that the difference between 20 and 25% doesn't seem as different as it actually is. So Kahneman and Tversky wanted both of these effects to exist simultaneously in one probability weighting function. And they did that. What should such a function look like? Well, on the x-axis, it has the true probability. And on the y-axis, it has the weighted probability. And I think I have a graph of it here. This is what it looks like. So in this graph I'm showing you, on the x-axis is the probability. Of course, that goes from 0 to 1. All probabilities are somewhere between 0 and 1. That has to be true. It's impossible to have any other probability other than between 0 and 1. It could include 0, it could include 1, but it has to be in that range. They're going to say the same is true for your decision weight. It has to be between 0 and 1. The most you could weight is 1. The least is 0. So on this graph that I have here, there's two lines. The one that's straight is the 45-degree line. That line is just a representation of true probabilities and how they would be weighted if there was no shifting going on. That's just a kind of a reference point for the true 45-degree line. The curved one, that's the actual probability weighting function. What does it say? Close to 0. Look how can you see my cursor? I'm moving my cursor around on the screen. It's like if I were in person, I would have a red laser pointer. I would point at this graph with my laser pointer, but now I have a cursor. Yeah, thanks, Pierre. See how it just shoots up at 0. Starting at 0, it goes straight up for a while, and then it starts to flatten out a little bit. Here's what that means. There's a certainty effect, where if something happens with 0%, which is certain, so you guys should think of 0% as certainly not going to happen, but that's still certain. 100% is that it certainly will happen. 0% is that it certainly will not happen. In either case, those are overweighted because something just a little bit different than 0% on this x-axis shoots way up on the probability weighting function. Therefore, even if something has a small chance of happening, like think about a lottery ticket. How many people buy lottery tickets like all the time, even when they have a really small chance of winning? Do we think that's because they would just really, really love getting millions of dollars? Like their utility functions are such that they have such a great utility of being rich that that's why they're willing to do it? It actually can't be that. That does not explain why people play lotteries like super lotteries that have a really Powerball type lotteries. If you think of a Powerball lottery, if you win, they fantasize. Okay, you know what? That's a very practical answer, Michael. Thanks for that. Michael is saying something which is different than what I was going to say, which is that sometimes people play lotteries just for the fantasy itself. Maybe they know they're not going to win, but they still enjoy this sort of fantasy. And it has to have some element of reality in it. Like they can't just make a fake lottery ticket to themselves and say, "Hey, look, I have a lottery ticket," and imagine what it would be like to win. They know that that's not real, so it has to have some element of reality. It's not pure fantasy, and I do agree with that. But let me just talk about whether or not, like, if somebody's really buying lottery tickets because they think like it's worth it, they really think it's worth it, they're going to do it. It's not because their utility function gives them a huge benefit for being really rich. It is true that being really rich would be great for them, for anybody. They would like that. But it can't be that because of the diminishing margin utility of wealth. Even people who play the lottery have a diminishing margin utility of wealth. The first million that they win isn't as good as the second million or the third. Or if they've already won $100 million, how much better is it to get another million? It's diminishing. It has to be. So that can't explain why some people might think, actually, it's worth it for me to buy this. I'm going to play this Powerball. I think the only real way to explain it and try to rationalize it rather than just thinking about the fantasy, which of course Michael brought up. Peter has another example, skewness, which we can talk about. After I finish this, maybe you'll think that it's kind of the same. But I think when people consider something like the Powerball lottery, which has a very low probability of winning, they're weighting it actually a lot higher than zero. Look at this graph. If you just go a little bit to the right of zero, your weight, in the sense that how much weight do you give psychologically for the fact that this thing might actually happen? This thing might happen. How much weight do I put my mentally in thinking about how much this could happen? It's way more than zero. And because of that, you may, quote unquote, rationally think it's worth it to buy a Powerball lottery ticket. And I think that's actually a pretty good explanation for why people might play these lotteries. Okay, Peter, do you want to talk about skewness? How's that different than what I said? I actually don't know what you mean by skewness.
I read it a long time ago because they were talking about trying to get lottery players who are the article was about prize linked savings account and trying to get people to switch their lottery consumption to savings, but they were saying that just the skewed outcome is what made people invest in lottery tickets instead of in savings.
What skewed outcome?
Just so the idea was, if you put your money in the savings account, you get a guaranteed small payment on your guaranteed small return. But if you spend it on a lottery, there's just that little chance that you get really rich, and people preferred the riskier behavior. And so what they did was they created a savings account wherein you don't gain any money guaranteed, but you also don't lose the money, but somebody gets all the interest from the period. So they could win $1 million from everyone else's interest, or you could win nothing. And people were doing that. But I think it's the same because they still talked about a curved decision weight in the article. But again, I haven't read it in like 5 years.
Yeah, and you know what? They may not be thinking about probability weighting functions, but it kind of sounds like it is the same idea. When you're talking about you said they prefer this skewness. The way I'm reading that is they like the gambles that include a small probability of winning a lot of money. Well, maybe it's because they've overweighted that probability. That would be another reason why they prefer it. They prefer it because they think it's a little bit more likely to happen than it really is, or at least they're acting as if it is more likely than it is. I think that's interesting.
Yeah, no, I think you're right.
Okay. Um, yeah, so I have that here, that the LA paradox can be explained by the probability weighting function. I've already talked about this quite a lot, but if you have any questions, ask me about it. I'd like to make this last point again, that risk aversion can't explain this result. The LA paradox is not due to risk aversion. It kind of feels like it is. It kind of feels like people are doing it because they want to avoid the risk of losing, like if they choose 3,000 over 4,000 with 0.8 probability, it may feel like, well, maybe just people don't want to take the risk and they're risk averse. And that's why they do this. Nope, it cannot explain it, because if you choose 3,000 over this risky gamble because of risk aversion, then the same risk aversion should cause you to choose this 3,000 with probability 0.25 over 4,000 with probability 0.2. Risk aversion doesn't have a certainty effect in it. It means you should be risk averse over all probabilities, not just the probability of 100%. And that's why it cannot explain. That's why it's behavioral economics and not just another standard economic model. Okay, I think we're ready to talk about the second part of prospect theory, which is the value function and the gains and losses. So I showed you this video. In my video, I talked about the public health decision where you could save people or not, which of course I got from the prospect theory article. I'm showing you a lot of duplicate things. You're actually going to get it three ways. If you read the paper, watch my videos, and listening to this lecture, I'm kind of bringing it up now for the third time. Sorry. But it really happens when you ask people these questions. And if you frame it as, how many people can you save? How many people can you save with this policy? People choose the safe option. When they're thinking of saving people's lives, they want to do it in the most sure thing way to save as many people as they can. However, when you frame a question in terms of how many people will die, not how many people will you save, but how many people will die, then people more often than not choose of course, I have to say these are hypothetical choices. No one would ever do this experiment with actually people's lives being risked. This is a hypothetical choice, but people choose the risky choice when you're talking about how many people will die. Did any of you guys watch that video and think to yourself, yeah, I think I would do the same thing? If I had to think about saving people's lives, I would say, I want to make sure that I save some people's lives, and I'll do that thing. Whereas if you're talking about how many people will die, you would say, I want to go for it. I want to risk the thing that means no one dies. I'm just curious if anybody's willing to tell me what they thought when they watched that video, or just right now. Would you psychologically think of it that way too? If it's saving lives, I want to make sure that at least some people's lives are saved. But if it's people dying, I want to take the risk to try to make it so that nobody dies. Rather than saying, well, I'm going to say these people are definitely going to die, but at least it won't be the full amount of the people dying. And I think part of that may be like a Hollywood thing, take the risk. You see them the same? Wait, okay, so Michael's saying that it doesn't, the framing effect wouldn't change his decision. And James, are you saying the same thing? You would always take the risk, or you would only take the risk in terms of saving? Okay. This is a really hard thing to do. In fact, it's kind of personal to people, kind of maybe what experience they've had with their stuff. I will say that it does actually happen, but usually not when you're presented with both. It's when like you take half the people and you give them the saving options. The other half of the people, you give them the dying options, and then seeing how they change. But so how do you resolve this? This is a paradox too, or at least it's an anomaly, because whether or not you want to take a risk to save people's lives or to let people die, it shouldn't depend on your reference point. If the decision is exactly the same, the outcomes are exactly the same, why should it depend on whether you're starting with the assumption that people will be okay and some of them will die, or that people will die but some of them can be saved? Shouldn't, but it does because of the reference point. Kahneman and Tversky are going to say we think of everything relative to some reference point, like our status quo. What happens if we do nothing? That's kind of our reference point. And if you change the reference point, it'll change. It could change people's behavior. It could change what they choose. For one thing, loss aversion matters. Whether you think of something in the domain of losses or the domain of gains, it matters how you feel about it. So how do they fix that? I'm not actually going to ask you guys to do this experiment. This is another one where when I used to do this to my students in class, and sometimes it works, sometimes it doesn't work. Anchoring always works with my students, but this doesn't always work. But the point of this experiment would see, do people like to take risks or play it safe when you're in the domain of gains versus the domain of losses? But in a lot of cases, people are risk averse when they're talking about gains, and they're risk seeking when they're talking about losses. How could this be? Why? Standard economics, you have a utility function, and either you're risk averse or risk neutral or risk seeking. You can't be both, depending on whether you're in the domain of gains or losses. But actually, with prospect theory, you can be. You can explain it with the value function. It depends on your starting point, which is the reference point. And the value function is concave in the domain of gains and convex in the domain of losses. I feel like it may be worth it or may not be worth it for me to try to draw that on a whiteboard. I thought I was gonna make this class a little bit shorter too, so maybe I don't have time. Okay, I think I want to have one more quiz before the midterm. I want to have quiz 3 on Wednesday, which is in 2 days. So maybe I will stop here and say quiz 3, how much of prospect theory can I put on quiz 3? I want to be able to talk about both the value function and the probability weighting function. So I want to show you the value function now, because I do think I might want to ask you about it on quiz 3. So here is, and I'm not going to do the whiteboard. Let's take a look at this value function. And I want to explain it. I want for it to make sense. Of course, the point right in the middle is the reference point. The way that it's drawn, the value of gains is decreasing, at least on the margin. And that makes us risk averse with gains. Because if I had to pick like a halfway point between some gain and the reference point, it would be much better to get that as a sure thing than to have like an equally likely chance to get nothing or something. Let me just say that the shape of this value function in the domain of gains is a reason for people to be risk averse. It rather just get the sure thing than take the gamble. You guys have any questions about that? The shape of this value function in the domain of gains means people want to be risk averse. Whereas in the domain of losses, it's the opposite. People would actually be risk seeking in the domain of losses. Why? Because it's worth it to take a chance to try to have zero losses because losses themselves are so painful. Now, as the losses get further and further away from the reference point, it flattens out. So I'm willing to take a little bit more of a risk. Yeah, I might lose even more by being risky in the domain of losses, but it's worth it for me to take that risk because I don't perceive the extreme losses as being quite as bad as, I'm sorry, on the margin. I don't perceive those losses to be even worse than a very big loss. So this function has that effect built into it. And one more effect I want to give you, and that is loss aversion. Loss aversion is built in here. It's kind of hard to see it in this particular one, but it should be that it's a lot steeper in the domain of losses than it is in gains. And that's another reason why people don't want to take gambles that could be either positive or negative. It's not worth it for them because if that negative happens, it'll be so painful. Or that's also why we have an endowment effect. If something belongs to be part of your endowment, to give it up would be very costly. Whereas if you don't have it as part of your endowment, to get it is nice, but I don't have to pay this really steep cost of not having it because it's not part of my endowment. Okay. I think those are the main points of prospect theory. The whole theory of prospect theory can basically be boiled down to applying this value function to every outcome where something could be better than the reference point or worse than the reference point, applying this value function to those outcomes, and then applying this probability weighting function to the different probabilities of it happening. Those two things, that's prospect theory in a nutshell. And if I ask you, so if on this quiz that we're going to have on Wednesday, I want to have a quiz on Wednesday, I could ask you about the consumer choice anomalies, or I could ask you about prospect theory. I'll try to make it not too deep into everything. You know what I mean? In other words, I'll ask you about the stuff we've talked about, not about something maybe referenced in the paper that we didn't talk about. I won't do that. Okay, do you guys have any questions about what we've actually done so far? We won't do these other implications of prospect theory. Let's save those for later. But for right now, we have the probability function that has two real effects, and that is the certainty effect. Things near 0 or 1 are very much overweighted, and it has the insensitivity to probability changes in the middle. Actually, I didn't say this before, but do you notice how this curve, how it's flatter? It's flatter than the 45-degree line. That's kind of what's happening, why it's insensitive to these probability changes, because this line here is flatter than the 45-degree line. So it's sensitivity to probability changes and certainty effect here. And then for the value function, there's, I would say, 3 effects maybe, and that is loss aversion, because this losses are really steep. It's called the reflection effect, that we are risk averse in the domain of gains and risk seeking in the domain of losses. And then the third effect is that there's a reference point where if the reference point changes, then we can have a framing effect. And that's it. Those are the main points of prospect theory. the framing effect, let me just be very clear what do I mean by the framing effect. If I express the exact same problem to you, but I change the reference point, then because it'll change the way this problem is framed in your mind, and it may lead you to make a different choice. And that is an implication of the value function, the fact that everything is compared made in comparison to a reference point. Therefore, if I change the reference point, I may also change your decision. Okay. And we'll have that quiz, maybe not right off the bat on Wednesday, sort of towards the middle of class on Wednesday, have our third quiz. And certainly, if you have any questions, you should ask me about them. I wanted to end the class a little bit earlier today because we had so many videos to watch. I sort of promised that was going to be a bit of a replacement of the class. So it's 1:30 now. We actually had an hour of class. Do you guys have any questions? Expectations over what's going to happen in the future? Have quiz 3 Wednesday. Then the next week we'll have a bit more of new material, which is prospect theory in the wild. Prospect theory in the wild is what we'll talk about on Monday, but also a bit of a review for the midterm. I will reserve some class time for you to ask me to review something that you just want to hear more about something from this class, and have that on next Monday. And then we will have a midterm during the class period next Wednesday. Not this Wednesday, but the Wednesday after, which is exactly what it says on the syllabus. We're going to stick to the syllabus. Let me know if you guys have any questions.